Hello friends, myself R.D. Mazen presenting my video on Runge Kutta fourth order method. Let us solve the problem. Solve by Runge Kutta fourth order method. Given differential equation is dy by dx is equal to 1 plus y square. Condition y at 0 is equals to 0. Means x0 is equals to 0, y0 is equals to 0. Then find y at point 2 and y at point 4 by taking x is equals to 0.2. Therefore, given differential equation is here, dy by dx is equal to 1 plus y square, and we call this as f of xy. And the condition is x0 is equals to 0 and the corresponding y0 is 0, and we consider h as 0.2. Then we have solution as y1 is equal to y0 plus 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. We call this equation 1, where k1 is given by h into f of x0 y0, and that is equals to, substituting the values, corresponding values, h is 0.2, f of x0 is 0, y0 is also 0, and therefore it is 0.2. f of xy is 1 plus y square. Therefore, using this, it becomes 1 plus y square. Y is here 0, 0 square is 0. And therefore, 1 plus 0 is 1. 1 into 0.2, we get that value as 0.2. This is the value of k1. Then k2 is obtained by h f of x0 plus half h and y0 plus half k1. Substituting the values corresponding, h is 0.2, function of x0 is 0, h is 0.2 and by 2, y0 is 0, k1 is 0.2 divided by 2, and therefore we get that value as 0.2 function of 0.2 by 2, we get that value as 0.1, and 0.2 by 2 again 0.1. And then obtaining the value by this, we get 1.2 multiplied by 1 plus y square. Y is here 0.1 square, and then by using calculator we get that value as 0.2 multiplied by 1 plus square of this 0.1 is 0.01, and therefore that becomes 0.2 multiplied by 1 plus 0.01 is 1.01, and multiplying it by 0.2 we get that value as 0.202. The value of k2 is 0.202. Then we try to determine the values of k3 and k. K3 is given by h f of x0 plus half h and y0 plus half times k2. Substituting the values, we get h as 0.2, function of x0 is 0, h is 0.2 divided by 2, and y0 is 0. K2 is 0.202 divided by 2, and then simplifying it, we get 0.2 f of 0.2 by 2, we get that value as 0.1, and this 0.202 divided by 2, we get that value as 0.101, and therefore this is 0.2 multiplied by x f of xy is 1 plus y square, and as per that it is 1 plus y square. Y is here 0.101 square and then performing by calculator we get that value as 0.2 multiplied by 1 plus 0.101 square, 1.010 multiplied by 0.2, we get that value as 0.202. K4 is obtained by h f of x0 plus h and y0 plus k3, and therefore it is 0.2 f of x0 is 0, h is 0.2, y0 is 0, k3 is 0.202, and then performing this with the help of this we get 0.2 1 plus y square, y is 0.202 square, this is 0.2 into 1 plus 0.202 whole square by calculating 1.041 multiplied by 0.2, we get that value as 0.208, and then substituting all these values here in this equation number 1, we get y1 nothing but y at x1, x1 is x0 plus h, 0 plus 0.2 we get that value as 0.2, and that is equals to y0 0 plus 1 by 6 times k1 0.2, 2 times k2 plus k3, k2 is 0.202 plus k3 is also 0.202 and plus k4 0.208, and therefore it is 1 by 6 times. If you perform this by calculator, that value is coming as 1.216, sum of all these terms multiplied by 1 by 6, we get that value as 0.203. This is y at 0.2. A required first value y at 0.2 we get as 0.203. Here the first step of first part is completed. I have completed the first part, and then to determine y at 0.4, to find y at 0.4, whatever these previous values we consider as x0 and y0. Let's consider x0 as 0.2 and the corresponding y0 as 0.203 and h as 0.2. Again repeat the same steps, means once again find the value of k1, k2, k3, k4, and whatever that value substitute here to get the y at 0.4. Once again the value of k1 as h f of x0 y0, it is h is 0.2, f of x0 is 0.2 and y0 corresponding is 0.203, and therefore it is 0.2. F of xy is 1 plus y square, therefore it becomes 1 plus y square. Y is here 0.203 and its square, it is 0.2. Performing by calculator, 1 plus this 0.203, 1.041 multiplied by 0.2, we get that value as 0.208. Always check the calculation by yourself, performing it on calculator. We have that value as 0.208. Then K2, H f of x0 plus half h and y0 plus half times k1, h is 0.2, f of x0 is 0.2, 0.2 by 2, y0 is 0.203 plus k1 by 2, that is 0.208 divided by 2, it is equals to 0.2 function of 0.2 plus 0.1, we get that value as 0.3, 0.203 plus dividing by 2, we get that value as 0.104, and therefore it is 0.2 1 plus y square, sum of, therefore it is 1 plus y square, y is here 0.307 and its square, and then simplifying by calculator we get that value as 0.2 multi 1.094, 1.094, and therefore it is equals to 0.219. It is the value of K2. Then we complete the calculation for K3, and K3 is obtained by h into f of x0 plus half h, y0 plus half times K2, and then substituting the values, h as 0.2, function of x0 0, 0.2, h is 0.2 by 2, y0 is 0.203 plus K2 0.219 divided by 2, and therefore it is 0.2 f of 0.2 by 2, 0.1, 0.1 plus 0.2, we get that value as 0.3, and this one as 0.312. 0.219 divided by 2 plus 0.203 by calculator, it is coming as 0.312, and therefore 0.2 multiplied by 1 plus y square, 0.312 square, and therefore it is 0.2 multiplied by 8, 1.098 into 0.2, we get that value as 0.220, value of K3. Then we perform for K4, obtained by h f of x0 plus h and y0 plus K3. Corresponding values we have to substitute, h as 0.2, f of x0 is 0.203, it is 0.2 plus h as 0.2, y0 as 0.203 and K3 as 0.220, 0.2 f of 0.2 plus 0.2, we get 0.4, 0.203 plus 0.220 is 0.423, it is 0.2 into f of xy is 1 plus y square, and therefore it is 1 plus y is 0.423 and its square, 0.2 into 1.179 multiplied by 0.2, we get that value as 0.236 is the value for K4. Then substituting all these values here in this equation number 1 to get the y at 0.4. y1 is nothing but y at x1. Here x1 is 0 plus 0.2, sorry, 0.2 plus 0.2, we get that value as 0.4, and that is equals to, substituting the values, we have y1 means y at x1 nothing but y at 0.4, y0 0.203 plus 1 by 6 k1 0.208 plus 2k2 0.219 plus 2 times k3 0.220 and k4 as 0.296, and then simplifying it by calculator, we have 0.203 plus 1 by 6 times sum of all this term is equal to 1.332 plus 1.332 divided by 6 0.220, and sum of this is 0.423 is y at 0.4. as the required value. Therefore, by performing in two parts, in first part we try to find value of y at 0.2, and then in second part we determine y at 0.4 by applying that Runge Kutta fourth order method. If you like my video, please share it as well as subscribe to my channel by pressing bell icon to receive the notifications for my new videos. Thank you. Thanks for watching.